I am Meghna Chakraborty. Good afternoon, everyone. I'm a PhD student. I'm in my fourth year under the supervision of Dr. Gates. And today, the topic of my discussion is the association between driveway land use and safety performance on rural highways. This is a brief overview of my presentation. I'm going to be talking about the background and objective of the study, the methodology the study used, and present you the findings and results from the study and end with conclusions. So let me begin by saying that nationwide safety on rural highways continues to be a serious concern. We see the statistics that says that population, less than 1/5 of population living in rural areas and rural roadways experiencing less than 1/3 of total vehicle miles traveled. Despite these facts, we see that 50% of traffic fatalities occurring on rural roadways, and also fatal crash rates are much higher on rural highways compared to urban areas. Now, narrowing down to Michigan in terms of road ownership, we see that almost 3/4 of all roads are owned by non-state agencies. And that's not unique to Michigan. You'll see similar phenomenon happening in many other states, especially in Great Lakes and Midwestern region. So that the fact that roadways are owned by, majority of the roadways are owned by non-state agencies. In Michigan, expectedly over 57% of all crashes occur on facilities that are owned by non-state agencies. So for sake of today's time, I would not go into the details of my literature study, but let me state the key takeaways of my literature review. I found that there are limited studies that assess the differences among various driveway land use types on rural roads, and even lesser information for county roadways. Highway Safety Manual provides guidance for considering driveway density while developing the crash modification factors in safety performance functions for both urban and rural roads, but it provides only a vague description for rural two-lane roadways that states a driveway serving all types of land use and all driveways that are used by traffic on at least a daily basis. So to that end, this study analyzes the impacts of driveway land use type on safety performance for rural two-lane roadways. Let me mention that this study utilized the data originally prepared and compiled for the Rural SPF project funded by Michigan Department of Transportation. So you would see that the analysis period is kept the same. Roadway segment related information was obtained from Michigan Department of Transportation roadway inventory file, or commonly known as sufficiency file, highways. And the similar information on road segments were obtained from Michigan Geographic Framework All Road Shapefile for county highways. These county highway data includes both federal aid and non-federal aid roads, and also paved and unpaved roadways, where the majority of the road segments are paved roadways. For the scope of this study, the segment type that was included in the study was two-lane undivided, and the speed limit up until 2017 was 55 miles per hour for all the segments. Highway Safety Manual recommends to exclude very small roadway sections due to the imprecision of crash location assignment to a small section of roadway. So it recommends to exclude the ones less than 1/10 of a mile, and the same has been followed in this study. So as you can understand, for crash frequency models, traffic volume information is traffic volume is one of the key predictors, and this information was obtained from roadway inventory. It was present in roadway inventory file for state highways for the period of 2011 to 2015, and this information was obtained from the annual traffic volume shapefile as maintained by Michigan Department of Transportation for federal aid roads. But it was much trickier to obtain this information for non-federal aid roads, and various county road agencies and regional planning commissions were contacted for that. And overall, only 29 counties, information for only 29 counties were available for county roadways, which were essentially included in this analysis, but traffic volume data was available for all 83 counties for state highways. Our next variable of interest is driveways. Driveway-related information was obtained from Michigan Department of Transportation driveway inventory file, and this provides the different driveway classification in terms of driveway land use types and the count of driveways of each type on each segment. So state highway data includes classifications such as residential, commercial, industrial, and field driveways. But this information was not available for county roads. So our research team manually collected this information from the Google Earth aerial view. But as you can understand that just by looking at the aerial view, it is tricky to distinguish between commercial and industrial driveway types. So the three broad classifications that were made for county roads driveway types were residential, commercial, or industrial together, and field driveways. These field driveways are essentially the ones that do not lead to any structure or a building, but due to overabundance of this type of driveway and relatively low utilization of this driveway type, we excluded this type from our further analysis and focused on residential, commercial, and industrial driveways. Several other information was part of this analysis, of course, crashes, which was obtained from MDOT traffic crash reporting system for the period of 2011 to 2015. Due to the large proportion of animal crashes in Michigan crash data, we excluded them and concentrated only on non-animal mid-block or segment crashes. Horizontal curvature related information was also obtained from Michigan Geographic Framework All-Road Shape file. And this particular study included curve count per mile or curve density information into the model. And for that, we focused on curves corresponding to design speed of 60 miles per hour or below. And the reason we chose this design speed was A, to have adequate sample size, and B, keeping in mind that the speed limit of several state highway segments increased to 65 miles per hour back in 2017. Several other cross-sectional features were part of the study, and they were present in the sufficiency file for state highways, but they're manually collected for county roads from Google Earth aerial view, and they include surface type, lane width, shoulder width, and type. Now moving on to the analytical approach, we developed safety performance functions by employing negative binomial model. So the background is we know that crashes are rare and random events and they're non-negative integers. So if you look at the crash data, you'll see that traditional linear regression model technique wouldn't have been appropriate. Poisson regression technique is a good starting point, but it assumes that mean is same as variance, which is most often not the case with crash data, because you'll see that most commonly mean is much smaller than variance, creating an over dispersion in the distribution. So negative binomial comes into play there. It adds an error term into the model to address this over dispersion. For this study, to account for unobserved heterogeneity across counties and sites, we also added 2 random intercepts of counties and sites, essentially developing mixed effect negative binomial models. And the reason we did that is, as you can understand, the way data is compiled, in the data set, you have each site repeated multiple times for the multiple analysis years. And also you have multiple sites from each county. So in order to account for that heterogeneity across counties and sites, we included these 2 random intercepts. These are the descriptive statistics of our variables of interest. That there's a lot of text, but I would focus on a couple of things here. If you look at the traffic volume and segment length, the average values are much higher on state highways. In terms of the density, we see that residential driver density is higher on county roads compared to state highways, but commercial and industrial driver density combined are much higher on state highways. Moving on to the crash frequency, we see that for all crash severities, the crash frequency is much higher on state highways. And this agrees with our expectations because if you think about it, while developing crash frequency models, two of the greatest predictors are segment length and traffic volume. And average values of both of those predictors are much higher on state highways. From here on, I would talk about the results, model results and findings. But let me mention one thing here, that you would find me restrict the discussion to only state highways and paved county roads going forward. And the reason I would not talk about unpaved road segments was because we did some preliminary analysis and our key variable of interest, which is driver density, did not seem to have any significant impact on crash frequency. So we excluded that facility segment type from our further analysis and focused on state highways and paved county roads. One more thing is we accounted for segment length by treating it as an offset and basically fixing the parameter estimate of log of segment length to 1 so that you will, based on this model results, the crash estimates you would see is basically crash frequency per mile basis. So these are the results for fatal injury and property damage crashes on state highways. You see that traffic volume is positively associated with crashes, and this positive association, so I mean by this positive association is increase in independent variable, there's an increase in dependent variables. So increase in traffic volume is associated with increased crash likelihood. And this effect is greater on fatal and injury crashes. Similarly, driveway density is positively associated for all land use types, but we see commercial driveway density to be having greatest effect. And when I looked at those limited research, I found that looked at different land use types of driveways. I found that this agrees with their findings too. And some of the reasons that the previous literature pointed out is commercial driveways experience more varied and wide range of traffic volumes. And it creates more conflict points and high turnover rates. And sometimes presence of drive-through creates very complex situation. And overall, the environment is much more complex, especially in peak business hours. Moving on to other geometric features, we see that horizontal curvature presence is associated positively with crashes with a much greater impact on fatal injury crashes. And this also agrees with previous research finding that pointed out that effect of horizontal curve presence is more detrimental to serious injury crashes. Lane width greater than 10 feet is associated negatively with only property damage crashes, and presence of paved shoulder is seen to have reduced crash likelihood for both fatal injury and PDO crashes. Moving on to the results of paved county roads, you'll see for most variables, the trend and direction of the association are similar to state highways. And I would point out the differences just in a while. Traffic volume seem to have, again, positively associated with crashes, with an inelastic relationship and a greater impact on fatal injury crashes. Driveway land use type seem to have positive association with crashes, with a greater impact of commercial and industrial driveways, especially for fatal injury crashes. For property damage crashes, we see that this driveway land use type didn't seem to have a significant impact. And a reason could be partially due to the fact that a very small proportion of segments, about 4% of segments of paved county roads experience property damage crashes that have any commercial or industrial driveway on it. Horizontal curve presence is also positively associated with crashes with much greater impact on fatal injury crashes. And lane width greater than 10 feet didn't seem to have any significant association with crashes. And lastly, we see that paved shoulder presence is shown to have a counterintuitive association with crashes. And when I was looking into why that may happen, I found that segments with paved shoulder present had close to double traffic volume compared to the baseline condition, that is segments with no paved shoulder presence. But I think additional research is warranted to figure out whether that's only the effect of traffic volume, and one direction of that could be isolating the segments that have paved shoulder presence as opposed to no paved shoulders, but with comparable ADT range. This slide shows the model results and compares between state highways and paved county roads for total crashes. We see the effect of traffic volume is greater on state highways. And that is also the case with driveway densities. For all driveway land use types, the effect is more pronounced on state highways. But on the other hand, horizontal curve presence is more pronounced on county roads. Lane width greater than 10 feet didn't seem to have any significant impact on total crashes, and paved shoulder presence is associated with lower crash likelihood for only state highways. This is a graphical representation of the models developed. We basically plotted annual crash frequency per mile for base condition and reference condition, and the base for both types of facilities. And the base condition is crash frequency on state highways or paved county roads without any driveways present, but fixing the other factors to its most commonly occurring values, such as lane width greater than 10 feet, paved shoulder present, and no horizontal curvature present. And the reference condition is keeping all other factors the same, state highways or paved county roads with 13 driveways. And this 13 driveways includes 10 residential and 3 commercial and industrial driveways per mile. These counts roughly represented the average driveway density values in the actual data. For comparison purpose, we also plotted the model estimates from Highway Safety Manual SPFs, and this excludes 12.1% of animal crashes, which was initially included in the actual HSM SPF. So what we see here is, even when set to typical values for driveway density, the estimated crash frequency for a given ADT is clearly greater than when no driveways are present. And this is particularly true for state highways, and we see that the effect of driveway density is much stronger on state highways just by looking at the difference of the crash estimates between the reference and base condition of paved highways and state highways, if we look at it side by side. Also, we see that crash frequency is consistently higher on county paved roads compared to state highways. And it is also slightly higher than the Highway Safety Manual estimates when you look at a very small range of ADT, approximately 2,000 vehicles, less than 2,000 vehicles per day. But beyond that range of ADT, Highway Safety Manual model estimates overpredicts basically crash frequency beyond that traffic volume range. So to conclude, this study identified that driveway land use has a significant effect on safety performance along the two rural two-lane undivided road segments. Commercial driveway density is found to have a stronger effect on crash frequency than other driveway land use classes. Impact of driveway density on crash frequency is stronger on state highways. And looking at other geometric characteristics, horizontal curve density, curve presence is positively associated with crash frequency, and greater lane width is associated with fewer PDO crashes only on state highways, and paved shoulder presence is associated with fewer crashes only on state highways. In terms of the contributions, this study provides further evidence that driveway land use types affect safety to different extents on rural road segments, and it contributes to the limited body of knowledge, particularly for county roads, which are much less explored, as I initially pointed out. Overall, the results of this study support previous research findings. This is the manuscript information in case you're interested in more details. And these are some of the references I use for just this presentation slides. And that's all I have for today. Let me know if you have any questions and comments, and thank you very much.
I can ask a question.
Yeah.
Okay. I was wondering if you ever considered mapping the National Land Cover Database type of information, somewhat to verify against the disposition on the driveway type.
No, we did not take that into account. This was based on how what information was available as part of the MDOT Rural SPF project. So land cover information was not separately looked at.
Okay, and sorry, I'm also on another call concurrently here, so my apologies to everybody, but some additional questions for Meghna. I guess one that I had, so you looked at curve count per mile and curve proportion, and I guess I'm just trying to understand those variables versus like curve specific variables like curve radius and looking at individual curves. Can you just comment a little bit on the audience as to why you took the approach that you did?
Yes, so actually I included curve density, only curve count per mile. Initial consideration was curve proportion, but what we did was our this study particularly looked at curve count for radius corresponding to design speed of 60 miles per hour and lower. But then we are extending this portion of horizontal curvature related information into separate radius bins. But this study particularly did not account for that. We are taking the cumulative curve count, anything that is corresponding to design speed of 65 miles per hour and lower than that. But we are expanding this horizontal curvature related information into further research.
Can you explain that a little bit more, Meghna? Some of your your research questions on the curve side of things that are going above and beyond what you've done here?
Yes, so we're looking at first the different curve, different bins of design speed. So between less than 40 miles per hour, starting from there to 40, greater than 40 miles per hour to less than 45 miles per hour, and all the way up to 65 miles per hour. Our data is available till 70 miles per hour, so around within that range. And we're also looking at, so radius is being considered corresponding to design speed. And we are also interested in looking at the distance between, so basically distance leading to a curve and beginning of a curve, and distance following the end of curve. So currently, I mean, we are in just the phase of data collection and yeah, we are in the initial phase of data collection for that, but we are considering different information, curve-related information to extend this analysis.
Can you explain the whole tangent length concept a little bit more and what you're doing with that?
Yes. So with tangent length information, what we are trying to see is kind of identifying the distance between two locations, so 2 points where a driver is expected to change the driving behavior or vehicle maneuver or lower the speed, vehicular speed. So we are considering the tangent distance a vehicle is moving in between two curves. And eventually the curves will also be split into different design speed brackets so that they correspond to a range of radius. I mean, radius information is accounted for as part of design speed.
So can you state that really succinctly in 1 10-second phrase what you're planning to do? So what is the comparison that you're ultimately doing once you collect all that data with respect to curves?
Yes. So we are trying to see what's the safety effects of safety impacts of distance between the tangent distance between two curves on crash frequency, and how do they compare between how do they compare with the effect of driving on tangent section as opposed to driving on a curve.
Okay, wouldn't you say that the primary comparison, as succinctly as possible, just boils down to a comparison of isolated curves versus curves that are in a series?
Yes, that is also
okay. That's what I was looking for.
Okay, yeah. Compound curves and isolated curves we are also looking at.
Okay, Meghna. Bill McConnell has a question, and that's, do you think the differences in crash frequency among land use classes is mainly a function of the volume of traffic utilizing those different types of driveways, or does the nature of the traffic using the driveways, such as size of vehicles, timing of use, also play an important part? Good question, Bill.
Yes, definitely. So you're absolutely right. When I was looking at the different rationale previous literature has given that why commercial driveway density seem to have greater safety, more adverse safety impact, and some of the things that is discussed over and over again is traffic volume is more heavier for commercial driveways, and definitely overall the traffic configuration and the business hours and the entire environment is more complex. And of course, the timing of vehicular peak hours is also important, but we don't have that information here. But I definitely think that those complexities are contributing to this greater influence by commercial driveways.
I guess real quick follow-up on that point. So we had actually done a study while I was still at Iowa State where we looked at the specific driveway types, and we used the ITE trip generation handbook to estimate how many trips we would expect to see at those driveways. And we did find some interesting relationships there, I guess, to Bill's broader point. So, I mean, that might be somewhat beyond scope here, but specifically, if you look at commercial driveways, there'd be a lot of variability. In industrial. The residential would be pretty consistent, so I don't think there'd be a whole lot to tease out from there.
Yes.
And then I guess my only other question on my end was just the effects of curves seem to be much more pronounced on the county network versus the state network. And I think there are several potential explanations for that, but I was hopeful you could comment on that a little bit, Meghna.
Yes, I think one of the things that I would mention first is design standards are higher on state highways. So even in terms of if you look at the observed data, the descriptive statistics, the presence of curve is also more prevalent on county highways. So I think those factors are contributing to greater impact on county roads. Also, several other things that come into play. For example, for when you experience a crash due to a curved section, for run-of-the-road crashes, for example, you need a more broader shoulder to combat that situation, sort of. So those things are much more maintain much higher standards for state highways. Several county roadways don't have any paved shoulder present. So I think in terms of getting away with potential crash is more difficult along county roadways in terms of those geometric characteristics as well.
Meghna, don't you think it also might have to do with the way that you're you're basically looking at the average design speeds? So how did you categorize these curves based on design speed for this particular study?
Can you
what were the design speeds of the curves? How did you categorize them in this study? What was your threshold?
We did it based on the radius and assuming 7% of super elevation. So
how are they binned? I'm sorry. How are the design speeds binned here? What was your design speed category?
Less than equal to 65 miles per hour. Less than 65 miles per hour.
And you just had one bin, one category, right?
Yes.
Okay. So do you suspect that design speed, the average design speed of curves on county roads was similar to or different from that on state roads?
Very good question. So yeah, you're right. That is different on actually there's a difference between state highways and county roads because county roads have much more curvatures. If you look at the descriptive statistics as well, the average curve count corresponding to a design speed of 65 miles per hour and lower is much higher on county roadways compared to state highways. So yes, definitely.
What do you suspect that how do you suspect the average design speed of curves within that category compares between county roads and state roads? That's the question at hand. Do you think county roads have a higher average design speed or a lower average design speed for the curves in your sample?
I think I see a lower curve design speed for county roads.
Right. And so that's probably playing a role in your parameter estimate being higher on county roads.
Yes.
Okay. So, and you mentioned this earlier that the next steps of your analysis, and I really wish you had included a slide that included how you were going to break down the curve analysis in the future. But one of the aspects is you are going to look at much deeper into the design speed aspects instead of just bidding everything in based on, if there was a curve out there that has a design speed of below 65 miles per hour, it gets lumped in binary, yes or no. Yeah. That's too aggregated. Like breaking things out is a little bit more, into design speed categories is a little bit better way of doing this. So,
Yes.
All right. Any other questions for Meghna? Going once, twice, 3 times. Again, just a friendly reminder, if you could please fill out the feedback form. I've repasted that link into the chat box and I can get that back to Meghna for her use moving forward. Thank you very much, Meghna. That was a very interesting presentation, and we look forward to hopefully having everybody back here again next week to listen to me talk for a much longer period. Thank you.